a quick reintroduction for Professor Beatrice Golomb. She is Professor of Medicine at the University of California, San Diego. She's an expert on Gulf War illness, and I just want to make sure that everyone knows that she's made very important contributions to several fields of medicine, not just Gulf War illness. And while actually after this presentation is over, I would like to actually put a link for her lab so you can get an idea of the extent of the contributions that she's made to the field of medicine. So we're going to have a continued question and answer and give her a chance to expand on some of the points that she didn't get to bring up and discuss from her presentation yesterday. All right, welcome, Dr. Golomb.
Oh, thank you so much.
So I'd like to start out by asking you a couple of questions. We had several people asking about methylation genetics and the relationship with oxidative stress. Could you comment on that?
Yes. So I'm going to comment through the avenue of a substance called betaine that you can get in some foods. And I'll happy to tell people why the preferred food for me is wheat germ oil, because it does lots of other wonderful things at the same time. And it turns out that betaine can either become glutathione or it can become acetylmethionine. So it can either support antioxidation or it can support methylation. And so in settings of high oxidative stress, the body naturally turns it over toward antioxidation and away from methylation. And this is in my opinion, an important avenue for why often people who have a lot of oxidative stress problems are found to be undermethylated. Now, a positive thing is that you will find on the internet that there's an alleged relationship between undermethylation and being extremely productive and CEOs of companies, et cetera, et cetera. I have several hypotheses about why that is. One is a hypothesis related to genetics, and another is that oxidative stress sadly impairs cell energy, and impaired cell energy leads to an increase in adrenaline, which can in fact make people in some cases more productive. We saw that some studies show that proximity to cell tower base stations leads to impairment in some forms of cognitive function, but increases in processing speed. And that's just sort of one of the avenues by which slight cell energy impairment leading to an increase in adrenaline can have good effects in some instances as well as adverse ones. And it depends on whether the person is adequately able to support their energy otherwise.
Great. Thank you. Okay, second question that I have. Now, did any of the diplomats develop electrosensitivity? And as everyone will recall, we're talking about in case not everyone saw your presentation, hopefully they did. You're going to be showing us some slides soon, correct? But we're talking about the diplomats in Cuba and in China, and the National Academy of Science report that concluded that many of the signs and symptoms reported by the American diplomats were consistent with the effects of direct pulse.
I'll say that my paper showed it first. I was one of the invited speakers to the National Academy's committee that came to the same conclusion that my paper came to. And I haven't spoken to all the diplomats, but I have spoken to some of the diplomats and also some people that have been reported on that had similar exposures in other foreign service workers that had similar exposures and similar symptoms. And the small subset that I've spoken to both comment that now they can only use a computer for a couple hours or for a few hours. So it does seem that among those that were significantly affected, at least a subset of them went on to develop electrosensitivity. Now, I've had people comment that, the diplomats' problem was electrosensitivity. And I would like to kind of distinguish electrotoxicity, or I guess I'd call non-ionizing radiation toxicity from non-ionizing radiation sensitivity. Just as in medicine, we refer to phototoxicity from ultraviolet light and then call it photosensitivity if people experience phototoxicity at a level of ultraviolet light that doesn't cause people problems, for the majority of the population. And similarly, for medical radiation, we refer to radiotoxicity. Confusing because it's not necessarily radio frequency radiation. And then we refer to it as radiosensitivity if they experience that toxicity at lower levels. And just as we have substances that we know are photosensitizing and radiosensitizing, incidentally including fluoroquinoline antibiotics in both cases. So we have individuals that are more sensitive to this non-ionizing radiation, meaning that they experience symptoms at lower levels. The levels that the diplomats experience based on the available meter reading are probably higher than most of us will experience in the civilian sector. So mostly we can say that they probably had non-ionizing radiation toxicity, but like in many of us, many people in the civilian sector, sometimes that high-level exposure can lead to sensitivity, as a lot of people have talked about at this meeting.
Talking about the National Academy of Science report about the Chinese and Cuban diplomats, are there international policy implications coming from the NAS report and this study? And who would be the cognizant agency when harm may have been caused by a foreign agent or government to US and Canadian employees working in a foreign country?
The irony in the Moscow setting is that the exposures were below allowable US thresholds, although they were above Russian allowable thresholds. You know, an issue that is worth mentioning is that even though their exposure was higher and a bigger fraction of them developed symptoms than is the case for the civilian sector exposed to sort of civilian communication sources, it is also the case there that not all presumably exposed diplomats developed symptoms. And this brings up two questions. One is, what are predisposing factors? And the other is, what kinds of features are associated with development of electrosensitivity? And this, I think, came up in some questions previously. Are there types of, EMS that are more likely to trigger development of electrosensitivity? And in a survey that we conducted a few years ago that included a little over 200 electrosensitive people and about 50 healthy controls, we asked the electrosensitive people if they recognized an inciting or triggering event, and close to 70% did. And by far the most common reported trigger were smart meters. But we've heard at this meeting, just as you will hear in many other sources, that there are many potential inciting triggers, and that these also include chemical exposures, as was also evident in our survey. So this sort of strong pulses that you get with smart meters or banks of smart meters seem to be particularly problematic for the induction of electrosensitivity, and this has been mirrored in some other people's survey studies as well. And I'll mention that almost every new release of an RF emitting device, and of course it's not necessarily just RF emitting, has been tied to some people reporting problems. The range of inciting triggers that we've heard is quite broad, including somebody who worked with wildlife putting radio collars on wildlife, and an architect who became electrosensitive after working with Bluetooth-enabled lighting devices. You'll see that the sixth one on our histogram is medical testing and treatment. So there's someone who's fairly well known in the electrosensitive community who developed electrosensitivity following exposure to dental x-rays. So ionizing radiation in that setting triggered electrosensitivity. And then you'll see the eighth on this one is chemical sensitivity. And that will bring us, I think, to the next slide, the first of the risk factor slides. And it's also been mentioned by a number of the speakers here that there's a lot of overlap with multiple chemical sensitivity, and some of the symptoms are in common with chronic fatigue syndrome, and that many people have irritable bowel syndrome or fibromyalgia, which is here abbreviated FM. And also this relationship to mold exposure and mold sensitivity has been reported. And I just thought that I would show that, yes, we have quantitative evidence showing that those with electrosensitivity compared to unaffected controls, they do have higher rates of each of these problems, with multiple chemical sensitivity being particularly strongly represented, but each of these other conditions being well represented as well. And you see that the p-values for each of these are less than 0.05, meaning that these are significant, or in many cases very strongly significant. And then I'll go on to the next slide. And
wait, just one sec. I have a question for you, Beatrice. Yeah. Just one quick question. If you could go back, what is your sense from your Gulf War illness population as well as this population, what percentage of, because what you've got here is 40% are reporting mold sensitivity and 53% report MCS. But do you have a sense of what, you don't have to give me a number, but do you think that a good number of these people that are electrosensitive are reacting to mold and reacting to chemicals and are just not aware of it? Is that a question that you've asked yourself?
I don't think exactly that is the case. I think that there are, for example, multiple different genetic pathways that contribute to shared vulnerability to different oxidative stressors, but there are some pathways that are more specific. And even within people with multiple chemical sensitivity, some people will react strongly to, for example, bleach, and other people with very strong chemical sensitivity for some things won't. So I think it is genuinely the case that these are overlapping but non-identical conditions. But there are absolutely shared factors. We've actually just completed a genetic study in veterans with Gulf War illness, which, by the way, is the first place I ever heard of electrosensitivity. The pesticide-exposed subgroup especially have high rates of chemical sensitivity, and then a subgroup of that group has electrical sensitivity. And we sort of replicated, but in a smaller sample, a finding that had been reported in a homogeneous Japanese sample, which is that superoxide dismutase 2, which is the mitochondrial localized superoxide dismutase. It's this important enzyme that helps to quench the nasty superoxide free radical, which is, and the mitochondrial superoxide dismutase is the main antioxidant in the mitochondria. People have adverse variants of those that are less effective at quenching those antioxidants. In our study, as in this Japanese study, we're more likely to have chemical sensitivity. And we found that this showed up in a smaller sample if you controlled for mitochondrial genetics, and particularly a mitochondrial heritable genetic line that comes primarily from Northern Europe, the haplogroup U, we found was significantly related to Gulf War illness severity, and I suspect it will prove to have a relationship to electrosensitivity as well. And I suspect that this SOD mutation will as well, and we're excited to look at that. But if you control for these mitochondrial genes, then the effects, you sort of sopped up some of the variability that reduces the ability otherwise to see the effect of these nuclear genes. So we think, as far as we know, this is the first study that looked at both the nuclear and mitochondrial genome together in this kind of condition. So I think there's a lot of overlap, but that there is also some separation between the conditions.
Okay, thank you. Do you want to go on to the next slide, or should I ask you another question?
Yeah, no, let's go ahead and go on to the next slide, which is sort of continuing on the theme of risk factors. And I mentioned that fluoroquinolone antibiotics, which I abbreviate FQs, which are antibiotics that also in a subgroup of people produce these chronic multi-symptom, in some cases persistent and progressive problems that encompass many different domains. And they do so through oxidative stress and mitochondrial impairment. And it was actually our work that contributed to alteration in the labeling, both first in the FDA, our paper was published in 2015, the FDA changed labeling in 2016, and then Health Canada followed suit in 2017, and then the European Medicines Agency in 2018, 2019. But fluoroquinolone antibiotics, which have been tied both to photosensitivity from ultraviolet light and to radiosensitivity from medical radiation, we also found had more frequently been reported to be used in electrosensitive people compared to controls. And what was especially striking was that adverse effects to fluoroquinolones were reported in about close to 50% of electrosensitive people who had taken fluoroquinolones, compared to 0% in, however, a small sample of healthy controls. And this probably is also a marker of some combination of pre-existing vulnerability to these sort of mitochondrial and oxidative problems, and potentially fluoroquinolones then advancing that toxicity. And then down a little further down the slide, you see that autoimmune conditions are significantly more likely. We think that some of the genes that tie oxidative stress to development of autoimmunity may be one of the features that influences at least some of the aspects that arise in electrosensitivity. The augmented autoantibodies, we think, are one of the factors that promotes symptoms in electrosensitivity. And also you see here that people with a first-degree relative, either with chemical toxicity symptoms or autoimmune disease, are also overrepresented in these groups. And then I wanted to go to the final sort of risk factor slide that we just thought was very interesting, and I thought you might think is interesting as well. We sort of had heard from lots of people that they had this stepped development of electrosensitivity, where they had one significant reaction, and then they got some symptoms, and then maybe later they had another major exposure, and then their symptoms worsened, and then perhaps another major exposure, and their symptoms got worse again. And we thought, might it be the case that there were previous exposures, not necessarily just to electricity, it could also be chemicals, but specifically to any electromagnetic radiation that stepped up their vulnerability in the preclinical phase before they, had their first exposure that led to symptoms. And a question was, well, how would they know if they're not paying attention to electromagnetic radiation and aren't having symptoms? And the setting where we figured they might know is the setting of electrical shock. And so we asked if people had had a significant electrical shock. And interestingly, close to a quarter of affected electrosensitive people, compared to fewer than 5% of healthy controls, reported electrical shocks. And you'll see from the comments below that these are not trivial events. 2 of them had actually been struck by lightning. Others had near fatal DC voltage accidents, et cetera. So we think this is also sort of an interesting phenomenon that might bear looking into some more in terms of the sort of precursor exposures that may be contributing to development of mitochondrial injury that leads to more free radicals being released on an ongoing basis, and therefore makes people more susceptible to new free radical exposures going forward. And chemical injury certainly is one factor that can do that, and electrical maybe as well.
Great. Fascinating, Professor Golomb. Thank you for your important work